Hello. Can you guys hear me? Good morning. How are you guys doing? Awesome. You awake? Come on. We're going to talk about how I think Ruby is the best language for building AI apps. Bit of a hot take. So, what is the languages that most people use when they think about AI apps? Python? JavaScript, perhaps? I think it kind of makes sense, right? So Python owns the AI space. I used to be actually a data scientist before, and we had like NumPy, SciPy, PyTorch, all of the training AI libraries. JavaScript owns the web, obviously, because it's the one language that can rule them all. And Ruby often gets passed over, which I think it's a mistake. Because AI app development was getting a data set, training a model, and then building an app around it. By AI app development now, well, the entire internet is the data set. Training a model like that costs millions of dollars. So we're left building an app around it. And, you know, how to do it? Well, you kind of do it this way. You just call some APIs. So the AI training library ecosystem that Python has built over time is irrelevant for AI app development. But you would ask, why Ruby? Right? So let's look at the top LLM libraries in Python with LangChain, in JavaScript with AI SDK, and in Ruby with RubyLLM. Let's look at simple chat. So this is how to do it in LangChain. You first need to import a couple things. First, you need to import an initChat model function, and then a human message class. And then you need to instantiate this chat model, and then pass the provider to that. So you need to know which models belongs to which providers somehow. And also have this array of messages with this human message class. It looks kind of strange to me. Let's see AI SDK. Well, you need to also import the modules for the specific provider you're using. And again, like, where do you keep that information? Then you generate the text, and you log it out. Let's look at RubyLLM. One require, one line of code. And you don't need to specify the provider. You can go even further than that, not even specify the model, because we have default models, just convention over configuration. What about multi-turn conversations? Now it starts to get interesting. So, of course, you need to import a bunch of things, because being explicit is what they're up to. And do the same stuff, invoking the model, and now we're appending the messages manually to our array of messages, the messages from the actual model, and then you append a human message again, and then you invoke it again. It seems pretty manual. This is something that you would have to do all the time. Same thing with AI SDK, and on top of that, you need to remember also these data structures and how they look like, instead of having like nice arguments of functions. And then also push these messages inside the arrays that you have to create manually. Why? I think we can do it this way, where you just instantiate a chat, and then you say hello, you get a response, and then you continue a conversation with just chat.ask. Streaming is also interesting. So they make you use a list comprehension, if you've never seen it. It's like a for loop inside an array, essentially, in order to separate like reasoning steps from actually like content in the chunks. And then you need to separate these two also with an if statement. Why? AI SDK does a similar thing, and you need to remember how these are called with strings passing around and equals, and it just doesn't fit my sensibilities. So this is what I came up with. You just iterate through the chunks in a block, and then since in Ruby print nil prints nothing, you can simply have both. What about multimodality? It gets even weirder. So these big libraries, apparently they don't even have a way for you to pass like images without you having to download the image and base64 encode it. Okay, so you do that. You have to import base64, HTTPX, encode it, get it, etc., etc. Put it inside these specific data structures, and then invoke the LLM. Can we do it in a better way? I think yes. This is my way of doing it. You just instantiate a chat, you ask, describe what's the weather in this image, and then you pass an argument to an argument with. And we actually figure out if it's a URL, if it's a local file, if it's a string IO, if it's an attachment, all kinds of support for all kinds of things, so that you can get going with what's important in building AI apps, which is actually figure out the prompts, figure out how to make tools, figure out how to make agents. And of course, we don't just support images, we support also videos, audios, PDFs, and newly also documents as well, and really anything that is supported by the model. You may have noticed I didn't mention AI SDK. Well, this is because the CEO of Vercel, which makes AI SDK, tweeted proudly that chatting with a PDF is the hello world of AI apps, and it's so easy with 20 lines of code, which I don't know if you can see. And this is what I tweeted back. What about tools? Well, they actually don't look that bad in LangChain, I have to give it that. I really like when people use decorators in Python, which essentially wrap a function with other code. And so they can use also introspection to figure out the arguments. But you still need to do all that ceremony with like selecting the specific model, passing the messages in a weird format, and invoke it. And for AI SDK, it's a similar thing, but I would argue even worse, where you need to use Zod in order to make an input schema, and that input schema needs to be in a specific format, and it's all kind of confusing and ugly. So I asked, can we do something better? I think we can. So this is the DSL for tools. Basically, tools can invoke anything in your Ruby code. They give agentic capabilities to LLMs. So an LLM is just an agent is just an LLM with tools. And in this case, you just define it like that. You pass a description. We use introspection as well. So in case you don't want to define like descriptions for your arguments, we just figure them out. And then you add it to your chat with the .withTool function, and you're ready to go. What about agents? Now we combine multiple tools together. We have maybe like a system prompt. It's the same thing, and you need to use this create React agent because it's trying to also connect to your front end. And you pass the tools, you pass the prompt, and you invoke it. But again, you need to know the model provider. You need to know all these data structures. Same thing with AI SDK. And again, tools, search docs, description, input schema. You need to pass objects in Zod and query. You need to see that this is a string, et cetera, et cetera. All kind of ugly. I think we can do better. So this is the DSL for creating an agent in RubyLLM. You can pass the model name if you want. You don't even have to. Instruction, you can pass them in line like that. If you don't, we actually figure out where you have your instructions. It's inside app agents, app prompts, the name of the agent, and then instructions.txt.erb. And you pass the tools like that. Very simple and clean. And you just use it just as you would use a chat object from RubyLLM. And it's not just that, right? So you can also do multi-agent orchestration, for example. And actually, this 13 lines of code has 4 agents, believe it or not. 3 of them will do security, performance, and style review at the same time using fibers. And you just have an async block, you pass the tasks, and the tasks just do a chat, and you can see the type of the review, and then the code is passed there, and then we return the type and review to the summarizer agent that then executes after them, and they're finished. Very simple. So this is a bit of a short overview of what you can do in RubyLLM, but it's really everything you need to build AI apps the Ruby way, not their way. So it can do chat, it can do tools, it can do agents, it can do orchestration, it can do a lot more things that I'll show you in a second. We support 13 providers, but also any OpenAI compatible provider, which is most of the other ones. We have an extensive model registry with 1,250 plus models. And also there are two local providers. One is Ollama, and the other one is GPU Stack. So you can run, open weights models in your laptop, or in your big desktop computer, or your DGX if you're really rich. And GPU Stack supports TensorRT, supports VLLM, supports all of the different inference servers that are out there. So you can also have all of your Hugging Face models, all of your ModelScope models, which are thousands and thousands of open weights models. And all you need to do in order to change between a provider and the other, or a model and the other, is to remember the name of the model and pass it to the model argument to the chat function. That's it. You want Gemini, you just do it like that way, and you want to have a same model from a different provider, like OpenRouter, for example. You just pass the provider. Same thing with Ollama. Now, this was the start of RubyLLM. I wanted to have a model registry, and that's why I made it in the first place, because I wanted to price my clients actually correctly. But how do you price your clients correctly? Well, you need to know all of the prices of all the different models, and they don't give it to you in a nice API. So RubyLLM actually provides that for you, and it has this 1,250 models. And it has context sizes, it has max output sizes, it has all the pricing for in and out, and cache read, and cache write, and whatever you have it. And also the type of capabilities, like does it have streaming, does it have tool calling, et cetera, et cetera. And you can refresh it yourself. I don't need to ship a new gem in order for you to have it. So you just call rubyllm.models.refresh. And you can also query it in different ways, like by provider, or if it supports vision, or whatever. But how do you go about actually tracking the costs? So you need to track the number of tokens. This is how to do it in LangChain. Can you spot where is the data structure where it tracks the tokens? It's here. And this was for OpenAI. Now let's switch to Anthropic. Where are those tokens? Now they're here. They're called completely differently. Different data structures for different providers. So you start to build a bunch of if statements everywhere. What about Gemini? Can you guys find it? I can't. What the hell is going on? So in order to do it with RubyLLM, we have like a standardized interface, and you can just have it in this way. So we have a token object, and it has inputs, output, thinking. And also now, from the last version, we also do the calculation for you for costs, so that you don't have to rebuild that little function everywhere. But most importantly, we actually standardized the way that tokens are counted, because every single provider does it in a slightly different way. Some of them will have caching tokens with the outputs. Some of them will have caching tokens outside the output. So we standardize in a way that your cost total, it will be the actual cost that you're paying. And we do it for all the providers. Even Gemini, which, by the way, is just about passing a new parameter. But why doesn't the library do it by itself? And this is with OpenRouter as well. And you can see there's also cache read. It's not only that. We don't only do chat, but we support pretty much everything else that LLM supports. So you can have a chat in one line, but you can also paint a picture in one line. And you can also embed some text in one line if you want to do RAG, for example. You can also moderate user content and transcribe meetings or whatever other audio you have. And most importantly, we have a Rails integration, which makes it very easy to go from 0 to a chat UI in less than 2 minutes. Let's see a bit of a demo. This is real time. It's the only time but the bundler is very slow. Then we add RubyLLM. And And then we use the install generator in order to create the migrations and the models that we need in order to start chatting right away. We do the migrations, and then we can load the models inside our DB so that they're nicely referenced. And we can generate a chat UI. Since we're using Tailwind, it uses the Tailwind version of it. If you wouldn't, it would use the uglier version of it. And we start a server, and we go into localhost/chats, create a new chat, we say hello, and here you go. That's it. It was less than a minute. And also you can see this is using Hotwire and Turbo in order to stream each single token, but also each single message as well. And here I'm just having fun with it. It agrees with me. I say Ruby over there. And we also have a small page with all of the different models that are in the model registry. So just to get started. This sounds like a lot of code, but actually this is how it looks in your app once you install it. So this is the streaming job. It simply finds the chat with the chat ID, and you have to pass the content of the prompt to that chat. The chat objects in Rails have the same exact interfaces as the chat objects in plain Ruby, so that you don't need to learn anything new about the RubyLLM API using Rails. So you can just do a chat.ask, you pass the content, and then you stream the chunks. In this case, you need to always check what is the last message. And this is because there is a so-called agentic loop, terrible naming, but basically means that each single ask function call could actually create multiple messages, especially if you have tools. So it can call one tool, then it can call another tool, then it can give you an assistant response. So you need to know which message you're appending things to. And then it simply calls this broadcast append chunk, which is a simple helper that you can see the code if you want inside your application. And that's it. And the controller also looks pretty easy. This is in the messages controller. The chat controller is the same, but simply creates a new chat. And the models also look pretty good to my eyes. So you have just access message that injects all of the code needed inside your models, or access chat, access tool call. And that also means that you can rename those as much as you want. You can put them into different namespaces, and everything's supported. And we also support attachments as well. You just need to pass as many attached attachments. And, well, it can also scale, thanks to fibers. So the problem with LLMs is that basically they create long streams, right? They have to wait from 2 seconds to minutes, if not hours sometimes. And the thing is, every time you're doing a LLM stream inside a background job, well, you're basically blocking an entire worker. And each single worker right now, at least in SolidQ, is basically taking one single connection from the DB pool, because this is how SolidQ was designed. It's playing it safe, right? So it's asking, what if every single job hits the DB at once, right? So there is a guardrail that asks you to set up the DB pool to be this size, which is processes times threads plus 2. So if you want to have, let's say, 300 different LLM conversations at the same time in your app, you need to have a DB pool of 312, which is a good guardrail, but it's a bad fit for us. And as I said, the streaming's long, but the database part is not, right? So there is, what is a streaming job from an LLM? It's reading a state, you stream some tokens, and it's mostly with Turbo. So it doesn't have to do much. And then you write the updates at the end, meaning the final messages. Fibers, as we've seen many times in this conference, are cheap weights. They are 20 times faster to create and 10 times faster to switch. This is, of course, like just that specific chunk of time compared to threads, because threads, they're not scheduled in user space. Threads are actually kernel threads as well. And with fibers, you can have one thread, but many, many waiting jobs. And as I said, no kernel thread per stream. And you can also make use of I/O multiplexing system calls like epoll, KQ, and I/O uring. So I wanted to have solid queue, but in fiber mode. And so I made a PR. And how does it work? Well, you just change this. Instead of the number of threads, you put fibers number. That's it. And now you can have one single backend with two worker shapes. So it's the same queue, the same API, the same jobs, but the LLM jobs are running in fibers, and the queue jobs or the other jobs that are maybe CPU bound or whatever else, they can run in threads. And I made a little benchmark, which you can take a look at. Probably you cannot see this link, but you can ask me later. And it wins all the time in RubyLLM streaming because it's IO bound. We're not doing much else. We're not doing a lot of DB calls. And this graph is showing the throughput advantage over the thread mode, right? So in a simple sleep, it's 7.4% faster. But in a RubyLLM stream case, it's on average 12% faster. And as you can see, this tells you that the benchmark is correct. CPU mode doesn't increase much. But why is this only possible in Ruby? Well, there's a bunch of things, right? So blocks are not a language feature. Blocks are a language feature, not just a function. So instead of doing just for loops over chunks, which you have to do in the two other languages, you can use blocks. But it's not only that. You can pass blocks around, and you can wrap them with other functions. And this is actually from the library itself. So you can, for example, wrap a stream block with something else, right? And we can create DSLs quite easily, because there is optional parentheses, symbols, keyword arguments. So it kind of starts to look like pseudocode. And also the implementation of that, it's really nice still. So we have this aesthetic sense in Ruby. And on top of that, we have sharp knives, like open classes. We can monkey patch them as we want. And in fact, we open them up and we add some extra features and extra methods to them in RubyLLM as well. What's my point? My point is that code aesthetics and programmer happiness are fundamental principles of Ruby culture. And let me show you also a case study. So there was another library that really liked the design of RubyLLM, and they ported it to JavaScript. This is called NodeLLM, and it has a similar shape. So you just pass the name of the model without the provider, and you just do a chat.ask, and you stream the chunks. Very cool. There's a bunch of other features, basically feature complete as much as RubyLLM is, and this is the reception. So he posted it on the subreddits JavaScript and Node, and he got downvoted to 0 in both. Only has, I think now it's 100 stars on 70 stars on GitHub, but this was after a month already. And these are the only comments he received. How's it different from AI SDK? Which may be a fair comment. But it's always fun with AI bros post stuff. They all look and sound the same, also totally unnecessary. And if you don't understand how Node.js works as a program and rely on AI, then AI is only going to magnify that disconnect. I don't even know what that means. So instead, let's look at RubyLLM reception. Somebody posted it on Hacker News. It got to #1, because probably there's a lot of Ruby people still on Hacker News, believe it or not. Instantly, thanks to that popularity, it got to a lot of stars, and right now we have like 3,900 and 6.6 million downloads, actually. And it's trending as a GitHub trending Ruby repository, and there's some nice comments, and it's used a bunch of places, including 37 signals, and we have an ecosystem where you can have monitoring, instrumentation, semantic routing, semantic caching, MCP, schema, templates, skills, evaluation frameworks, open telemetry support, you name it. It's really nice, and thanks to the community for all their work on that. And also we have something new from last week. We have image editing support. So you can just pass the like the dot width argument, and you can edit any image. You pass to the paint function. And the cost helpers and token counts are normalized, and they're all there for you. And we also have slightly cleaner tools. Before, you needed to always pass a param function with like some description of the param. Now you don't have to, so it looks even better. And we have also additive callbacks instead of just the on new message or on end message, which were replacing callbacks. Now it looks more like Rails. So my thesis is that RubyLLM makes LLMs simple and elegant. And together with Rails, which is the fastest way to ship real web apps, and with the fact that Ruby has the best developer community in the world, I think Ruby moments in AI can be here. So I hope you guys try it out and use it and share what you've built. I also do a little bit more open source stuff. So I created also a monitor config terminal user interface for Hyperland and some other docs theme for Jekyll that looks better. And also a Kamal backup for backing up your Rails apps. And I hope you try them out. Thank you.